Alright, so in this problem what we have is a compound with an empirical formula of this. It says if the molar mass is 309 grams per mole, what is the molecular formula? Before I go any further, empirical formula just means that the formula has been reduced in terms of its subscripts to the lowest number that it could. For instance, we won't usually write sodium 20, chlorine 20 for sodium chloride. Instead, what we're going to do is we're going to reduce that to its empirical formula, and its empirical formula again would be as reduced as you could. And that's what we see here. That's what they give us. Now, this molar mass does not correspond to this formula. Rather, they're saying this is your most reduced, but somewhere out there is a compound that has the same mole, has the same ratio, 4 to 11 to 2 to 1. And it has 390 grams per mole. The way that we're going to do this is first we've got to figure out just how much, what's the molar mass of this empirical formula. So to do that, using your periodic table, you can get to that pretty quickly. So the molar mass, C4, H11, into O, from your periodic table would be 4 times 12.01 plus 11 times 1.01 plus 2 times 14.01 plus 16. So if you do this, you crunch through your numbers, you're going to get a number of around 103.29 grams per mole. So we know the empirical formula has a molar mass of 103.29 grams per mole. So the only catch to this is for you to recognize that a molecular formula it is simply going to be some whole number ratio of this guy to this guy. So what we can do to figure out what that ratio is if I take this 309 grams per mole, I want to know what is that ratio from it to the molar mass of our empirical formula. You'll notice we don't even really have to crunch through this. You can see that it's pretty much 3, which means then that the ratio between this compound to this compound is by 3. So now we can figure out our molecular formula. I therefore know it's going to be carbon. Again, we're going to multiply all of these numbers here by 3. That's all that says. So that's carbon 12. H, 33. Nitrogen would be 6. Oxygen would be 3. So this would be our molecular formula.